Welcome back to my channel Techno Namaste. I am Dr. A. Navanita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology. So today I am going to discuss a topic that is nothing but subtraction instruction. So already in my previous video I discussed about add instruction, and now I am going to discuss a subtraction instruction which is used in 8086 CPU. So whatever already I told you, whenever a CPU is manufactured by any company like Intel, TSMC, any company, once they manufacture the CPU, they are going to develop the instruction set. So they are, once instruction set is developed, instruction set is nothing but a group of instructions which are used to make the CPU to do certain operation. Okay, using those instructions which is given by the instruction set of manufacturer, that we have to develop the program, and that program will make the CPU to do certain work. Okay, so here in this one, the instruction which we are going to discuss is nothing but a subtraction instruction. So in the syntax for subtraction instruction is nothing but sub AX comma BX. So whatever the AX and BX you are using here, this BX is said to be the source operand, AX is said to be the destination operand, and sub is said to be the opcode which is going to work on this operand. So opcode is nothing but operation code. Okay, so here in this one, whenever this what is the instruction? Instruction is nothing but a command given by the programmer to the CPU to do certain operation. So what is the command now the programmer is giving to your 8086 that to do the subtraction operation. So here to do the subtraction operation in 8086, that is nothing but CPU. In the CPU, in the ALU, it is going to do the subtraction operation. So how it is going to do the subtraction operation? By whatever the operands you have given, that is source operand and destination operand. Once this instruction is executed by the CPU, what it does, the content of AX will be subtracted with the BX, that is destination minus source operand it will do, and the result it is going to store in the AX. Okay, instead of 16-bit, already you know, everyone, most of you know that AX and BX are nothing but the general purpose registers which is present in your 8086 and capable of storing 16-bit data. So instead of 16-bit data, if you take the 8-bit data, instead of AX, AL will be taken and BX, BL will be taken. So here in this one, whatever the 8-bit we have, the destination minus source will be done, and the result is going to be stored in the AL. Okay, so here in this one, whatever we have discussed here, this instead of AX, here we can take the operand as a user data also, like 1 2 3 4 H. Okay, so instead of user data, here we can take one of the source operand as a memory location, like 5624 H. Okay, so whenever a bracket with a number is written, this represents the data present at the memory location which is present at the address given inside your bracket. Or instead of giving direct address value, we can give a register also where it is going to hold the address. So data present at the address of the memory location, where this address is present now, which is holded in the DI. Think DI is holding some value like 3156. So this value, whatever DI is holding, that is destination index register which is present in 8086. There it is going to it is going to hold the data. Think at this address of the memory location, here it is holding a data B. So this data B will be made to load in the AX. Okay, so here instead of this DI, okay, so here think BX is used earlier, which we have used. Here at the destination you can make use of memory location. Think I have used some address of the memory location like this. So whatever the data which is present at BX, it can move to the destination operand to the data present at a location of 1985. So here what does it mean then? You have taken the source operand as a register and destination operand also register. Source operand is user data, destination as a register, or source operand as a memory location or destination as a register. Now you have taken the source operand as a register, or you can take it as a destination operand as a memory location. Okay, but one thing you have to remember that source and destination you cannot use both as a memory location. Here SI is nothing but source index, the data present at the memory location whose address is present at SI. So here also you are taking memory location of the memory, here also you are going to take the memory location of the memory. So two memory locations, the source and destination, cannot be used as an operand, and this is the illegal way of writing the instruction, whether you take add instruction or sub instruction. Okay, these points you have to remember. Now what is the operands we have taken here? We have taken a destination as AX and BX. With this one we will discuss one example how you are going to do, and theoretically and practically how you are going to check it. So think I have taken, because AX is how many bit of register? It is a 16-bit register, isn't it? So here when it is this executed by the CPU 8086, it is going to subtract destination operand with the source operand, and result it is going to store in the destination. So think AX is holding the value in your AX is nothing but F9. Initially it is holding F9 ACH. H represents that we are going to take the hexadecimal number. Okay, so BX is holding the D4C7H. Okay, I have taken one example, you can take any numbers. So because it is a 4 hex digit number, once H is written, it represents that we are going to consider hexadecimal number. So 4 hex, 1 digit, 2 digit, 3 digit, 4 digit. Once 4 digit hexadecimal number is taken, this will be accumulating how many bits in the AX register? 16 bits. Why 16 bits? Because each one hex digit equal to 4 binary bits. 4 hex digit will be equal to how much? 16 binary bits. In the hardware, how it will be stored in the AX? If we take AX is equal to F9 ACH I have taken. So how it will be stored? C is nothing but in hexadecimal 12. So 12, how it will be stored? Each hex digit equal to 5 binary bits. That is nothing but 1100 it will take. A means what? 10. 10, how it is going to store? This one 1010, 8 plus 2. Next 9. 9, how it is going to store? 1001. Then F, how it is going to store? 15. 15 is nothing but 4 binary bits, 111. So all these 16 bits will be stored in the AX register, which is present in the 8086 in the form of binary bits. Here we have taken the hexadecimal for the user to understand in the programming. Okay, so here in this one, how it is going to do the subtraction, that we will see now. So here in this one, C is nothing but what? 12. So that 12, you see whatever you have taken, that 12 you are going to take here. So 12 and 12 you are doing subtraction, isn't it? 12 minus 7, how much? 5. You have taken 5 here. Next, what you have taken here? What is the number you have taken here? A and C, isn't it? So A and C means what? A is nothing but what here? 10. Okay, so A is a 10, and whatever the value you have here in this one, whatever you have, because you are doing subtraction, 10 is this and this is 12. So this is a lesser number. 10 you cannot subtract with the 12. So you need to take the borrow from here. Here you are going to, because you are taking one borrow, 9 minus 1, it will become 8. Here because you are doing hexadecimal, that borrow 1 is nothing but equal to 16. So this 16, whatever you have, 16 plus 10, how much here? 26. Okay, so whatever the 26 you have, that 26, what you are going here, you have to subtract with what? With the 12 you have to subtract. 20 minus 12 equal to how much? 14. So that 14 in the hexadecimal, how much? For E, isn't it? So the subtracting whatever the borrow here is nothing but 16 here. One borrow if you take means that in hexadecimal it is equal to 16. That 16 you should be added with the whatever the number you have. What is the number you have here? 10. 16 plus 10 how much? 26. And this 26 total number with what you have to subtract? C. C is nothing but what? 12. 26 minus 12 how much? 14. 14 in hexadecimal how much? E. So that E you have written here. Next what you have here? 8. 8 4. So 8 4 how much? 8 minus 4 how much here? Already you have 9 was there, you have taken one borrow. 8 minus 4 4. And F you have. F is nothing but what here? 15. So F15. D is nothing but what? 13. So 15 minus 13 how much? 2. Isn't it? So here 2 4 E F H we have done. We got it after subtraction. So whatever the subtracted result you got it, this subtracted result will be stored where? In the AX register. So here this is a theoretical way we are going to verify. So in the practical if you want to see, you have to use the software DOSBox or MASM. So in this software so you can run the program using the subtraction instruction. First load the value 16-bit number in AX register and then load the number, this number in the BX register. Next you go for this subtraction instruction, then you see the result in the AX. So AX should contain whatever you got it. So in the system you can see installing this software. Okay, so in this way the subtraction instruction is going to be used. If you have any doubts or anything, you can place a comment or you can put your number so that I can send whatever the doubts you have to your number. If you like my video, put a click if you like the video, click it, subscribe it and place some comments and share it so that it will be useful more students who are not aware of the basics for the subjects which they are going to deal it. Okay, thank you once again.